Hello, good afternoon. Sorry about the delay. I am pretty bummed about it. The streamer software I was using was just being a little bit pokey today. Okay, we're ready to get going. And I'm going to turn this off so I don't have to listen to myself. So today we're going to be writing a Twitter anonymizer. And let me, hi Ryan, start with some Twitter data. Why not? Oh wait, I'm already in here. I think I'm gonna start with celebrity tweets for reasons that will soon become clear. I think we have just like a celebrity tweets data set. A lot of Elon Musk ones. Tweets. Twitter. Ryan says, I had to play with the last project you did. If you look at my fork, there might be some useful code. Tip, I will definitely take a look at that. I do plan to go back to that, but I have a fire under my butt to do this other thing. And I'm also sick of being frustrated by data structures in Python. Okay, yeah, let's do this. I'm fine with this. Because it's verified users. So the thing that we are doing today is we are, you can see our shiny new Analyze Data button. We're going to build a Twitter anonymizer. So when you are working with Twitter data, if you want to share like a quote, like an example tweet, if you share the exact text of the tweet, you can find it through Twitter's reverse search. And that breaks anonymity. And there was a recent study on Twitter users to see what they found out about being part of research, to find out how they felt about being part of research. And a lot of people were like, I'm fine with being in research, but I do want it to be anonymous. And you can't just take the username off, because then you can do this reverse search project. And the Twitter search API that you use when you're on the site goes back way further than the one that you use as a developer. So even if you search as a developer and you're like, oh, just programmatically, I can't find the tweet, somebody who reads the paper and is like, oh, this person's wrong, and I'm going to go online and harass them for whatever reason, would still be able to find the tweet. So we are going to anonymize them, tweets, by changing words. TidyText is the thing that I'm looking for here. And to just start off with sort of a pseudocode of the algorithm design, I want to split into word tokens. Then I want to, well, I'm glad I ran that cell that has one line of comment in it. That was a good thing. Sort by frequency. So we're going to change the least frequent tokens, because those are going to be the most unique, and those are going to be the easiest to identify in the tweet. Find the 20% that are the least frequent. This is going to be based on some corpus of frequency. And then we're going to, I guess we could also start with just using our Twitter data set that we are using as a corpus, but you don't necessarily know that your sub data set is a good representation of more diverse language. That at least 20% of words. And then we're going to change all of those words into semantically similar words for using embeddings. And I haven't picked my embeddings. Some sort of embeddings, and including some non-deterministic noise. Because this is something where you don't want to be able to reproduce this right away, right? If I know that if I put in pig, I get out sow every single time, I'm going to get to the point where someone who is very familiar with this can look at my anonymized tweet and be like, oh, the original tweet said pig, and then search for the original tweet. And of course, you won't do this with all of your data, probably. You'll just do this with the ones you're like quoting in your paper. So it's okay to have this sort of really non-deterministic process. I am personally fine with that, and I think that is good. Tweet anonymizer. Good for this particular anonymizer use case. Oh, hello, Ronnie. Anonymizer. All right. Word tokens. So let's start by reading in our data. Oh, I should read these first, huh? And it is in the input folder, and let's just do the raw ones rather than the... No, actually, let's see what they did for cleaning, because that's going to be important. Let's open it in a new window. Take a look. You like that? I really like that, because I'm always opening it in a new window anyway, and I don't need to right-click and then click the other one. Publicly traded, tagged with a company they are tweeting about. David Nunes says, why embeddings and not a knowledge base with synonyms, etc.? Simpler. Embeddings are highly dependent on data, and similarity may not reflect meaning at all. Really good point. So the main reason is that I want this to be sort of a general algorithm that will work well cross-linguistically. And there are fewer languages that have good knowledge base support than you can train embeddings on. Yeah, we could try both. This is just sort of a first pass. So I'm just trying to see the cleaning that was done. The influencers, blah, 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 blah. Tweets.csv file. In the content section, if one of them tweeted about a company in the cleaned file, then it would write the tweet to the database. Okay, so the cleaned is a smaller set of companies. I'm okay with that. I don't need a whole bunch of tweets for this. Oh. All right, there we go. Oh, I see. This is the name of the stocks, not the tweets. Gotcha. Does it have tweets? No, it doesn't have tweets. All right. So this Twitter data set actually has no tweets in it, which is going to be a problem. You know what? We can leave that. Let's just try an example tweet. Let's just make one up because it's not super important what the tweets are. We can go through and do testing. I just want to get it sort of off the ground and running first. So let's go to Twitter really quick. And I'll get one of my own tweets. And here's me complaining about my streaming software. The last 2 times it updated, and this time it didn't update, but it just went really, really slow. Okay, nope, yep. Copy that. All right, put it in here. Bam, okay. Oh, that's a good question. I have not thought about emojis. I'll leave myself a little to-do at the top. To-do, think about emojis. All right, I'll put that off later. David says, fair enough, but still the dependency on quality embedding should be a disclaimer somewhere. Oh yeah, definitely. I just want sort of a word that is similar in some axis so you don't change the meaning of the tweet too much. All right, so we're going to split this word into tokens. And I'm going to look up the TidyText documentation because I have immediately forgotten everything about it. Title. Okay, so this is from the books. I think I can just split. I don't think I need that whole folderol. I think it's string.split. Argument pattern is missing. Sample tweets. Oh. Yeah, it's because I can't spell good. And this way of tokenizing is sort of a little bit of a dumb way of tokenizing, and it's not going to work for languages like Thai that don't use spaces. Won't work for languages without spaces between words. All right, so now I want to get the frequency, and I should say split words. And I know I'm doing this sort of hodgepodge, but I'll go back and clear it up later. I have a very tight deadline today. I have somewhere to be at 5:15, so I have to, you know, get through this. All right, and now we want to sort by frequency. So I know we have frequency data somewhere. I'm pretty sure I've actually uploaded some frequency data sets. Ooh, internet's slow today. Frequency. Here we go. English word frequency. I feel like this one might be mine. Yeah, this one's mine. All right, so let's add it with our shiny new data sets adder. English word frequency. It went away. Was it because I misspelled frequency? There we go. Let's add that. It's got to restart. And let's just run all the cells really quick. Excellent. Okay. So, example tweet for testing purposes. Testing purposes only. And then we'll go back and see if we can improve on that. Okay, sorting by frequency. Frequency data. I imagine most NLP packages will have this in their sort of utility functions. I think NLTK has it. I don't know about Spacey or like Blob.io. There's a bunch of different ones. What format are you in? Is it a CSV? It's a CSV. That's lovely. Under CSV, unigram. Oh, yeah, that's not gonna work. I know how to read in files. Sorry, I've been very, very, very busy this week, so I am feeling a little bit brain dead. So the first thing I want to do, I think actually I want to make this into a data frame just to make my life easier. And I want to call it words. And then if I take a look at split words, it should, oh, well, that's not ideal. Is this one of those things where it's listed? Because I want each word in a different row, because I'm going to be doing some joining. Yeah, there we go. So the first thing I want to do, actually there's another step in here, which is replace out of vocabulary words with unc. So that stands for unknown token, and that's fairly standard. Maybe I should probably do these two steps together. Because if I just take the, so this is the top, what did it say? Do y'all remember? So it's the 1/3 million most frequent English words on the web, which is actually not that many. And I think they're sorted by count. So if we have words that are outside of the top 1/3 million, they might be very discriminative. So I am going to, I think it's right join. I always get my join directions backwards. Frequency data, word, and so I think I want only the ones in here. Split words, word, words. All right. This will either crash my kernel or be the thing that I want. No applicable. I don't know the card. Oh, you know what I should do instead? I should call this word instead of words. And then that is, and then we should say by equals word. By must be a named character vector list or null for natural joins. All right, I did it backwards, so it should be the other way around. Because I want only the words that are also in this other one. Yeah, absolutely. So some of these I think are showing up as NA because they've got capitalization and they've got punctuation in this. So we're going to remove capitalization and punctuation. And I think there's a TidyText way to do that. TidyText remove capitalization. TidyText, is it clean text maybe? Let's just look at the function names. I'm sure that will jog my memory. Corpus tidiers, dictionary tidiers, parts of speech. Let's see what corpus tidiers do. Tidy corpus object. Let me make this bigger. From the quantita package, tidy returns a tibble, excuse me, with one row per document. Blah 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 blah. That's not what I want. R remove all punctuation. You can see that I have done this before. Text clean. And strip, is this just going to strip white space or will it strip everything? Strip text of unwanted characters. Text variable. Character vegetable or symbols, it should strip should keep. If the default is to strip every symbol except apostrophes and the double tilde, the double tilde is included for convenient means of keeping word groups together in functions. Okay, that is what I want. So it's text clean and it is strip. Actually, is this a is it installed? Text clean strip. Because if it's installed, I just need it for one function. I don't need to load in the whole one. Yeah, that works. Beautiful. So I'm just going to add that, and that's just gonna the end. Oh, this is awful. Pre-process text. And the reason you want to do those is because the join is case and punctuation sensitive. So now when we do our little join, we have to do all of these things first. So when we look at this, we can see we've removed everything but apostrophes. We've also removed some but not all emojis, so that's a thing that's happened, and I'm just not going to worry about it right now. But I noticed that for sure I did. Excellent, and now we can see that weeks, I'm, tweets, can't, and shh are ones that don't have counts. And let's also remove all of our string.sub, and I'm just gonna do it everything, and I'm going to replace apostrophes with nothing. NA is introduced by coercion. Let's quickly print out example tweets. Did I do it backwards? It's entirely possible that I did. NA. All right, so I think I want to replace with nothing things that are apostrophes. Nope. Let's see. R remove apos. Oh, here we go. It's just apostrophe remove equals true, so it's just an extra function that we add. I don't need to mess about with all of these. And it was. And personally, I like to do just T and just F instead of true false. Get rid of that pipe because we're not piping to anything. There we go. Beautiful. Go through this whole rigmarole again. Excellent. Yes, and now you can see the only things that don't have counts are tweets and the sh emoji, which I'm fine with. So, what we're gonna do is get frequency for words in tweet. And this is not going to be super efficient to loop over 100,000 times, but since you're only going to want to do this for tweets that you're quoting in your paper, I'm not going to spend a lot of time going through and optimizing this. All right, so we are going to do some piping, and this is where R really shines in my view. So we're going to filter count. Oh. Is .na count. Excellent. And then we are going to mutate word equals unc. There we go. Actually, no, I don't think we need to do this now. Nope, 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 nope. Why can I never remember the gosh darn block comment shortcut? Well, I don't remember it, and that's fine. Yeah, we don't actually need to do this now, I don't think, because we can do it. We're going to sort of reassemble the tweet at the end. So I think we can get rid of this now. All right, so what we need to do is tweet freak, and we want to arrange, I think is the verb that we want, by count going down. Oh, by count going up. And then I think you can take the top 5. I don't remember how to do this. Tidyverse sort and take top 5 rows. Yes, top n. There's already a function for it. Y'all, I love the tidyverse. So we need to find out what n should be. So here, let's do 5, just to make sure that it works. Selecting by count. Is there a bottom n? Number of rows to return. Variable used for ordering. If not specified, it's default / variable in the tibble. Code and evaluated tibble default filter. And it is, in fact, you flip it on its little head like so. So coding, tweet, anonymizer, and can't are the least frequent words. And they're not return sorted because I didn't arrange them. So n equals dim1. Actually, I think I can do tweet freak words, and then I want the length And then I'm going to multiply that by 0.2, which is 20%. And then I'm going to take the floor of that. I think it's just floor in R. Our floor method, my largest integer value that is not greater than, less than, or equivalent to a individual number or expression. We're rounding. That's all we're doing. We're just rounding. I know you need to be super precise all the time, but you know. Nope. There's already a word for the thing that we're doing. And that's N. So this is that we don't replace all the words because that's going to make it maybe, you know, less helpful. So this should be 20% of the words. Coding, I'm, automatic, tweet, anonymizer, can't, reverse, and searched. Okay, so least common words. I think I mentioned the reason we're changing the least common words is because they're going to be the most identifiable in the tweet. And we're probably going to change them to other very uncommon words, but that's okay. All right. Oh, this is gonna drive me nuts. How do you, is it J? I think it's H? Yeah, it's H. How do you block comment? Oh, that's nice. You can edit shortcuts. Blah, 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 toggle outputs. Edit mode. Comments. It is control the slash pointing that way. All right, so control that slash. There we go. So now we'll only get the, we won't actually see any output. So we see the selecting by count. That's from right join. It gives you some helpful things. Okay. Now we need to find similar words for each of these words. I'm gonna make this bigger so I'm looking at the middle of the screen. Oh, Ryan just said, thank you. I figured it out. In RStudio, it's Shift Control C, I think. I don't know, I just do it automatically, and when I do it automatically and it doesn't help me, I'm very miffed by it. Okay, so I have frequency. I need to know semantic nearness, so I'm going to ask for embeddings. And I know we have a lot of embeddings on the site. We've got the glove, we've got emoji embeddings, we got Word2Vec, we've got Spanish. You can see I've uploaded some of these. Fast text. Two emoji ones, word embeddings. Where's glove? Oh, here they are. Yeah, I'm just gonna use glove because they're the ones that I've worked with before, not because I think they're necessarily the best. And this is a big baby. This is a fairly large load, so. All right. So we're gonna run it all from the top, and hopefully it'll all run correctly, and I didn't delete something that I actually needed to keep. I don't think I did. So I should be able to see least common words here. Yep, and I just need to find words that are similar to them. So I know at some point I wrote an R kernel that did this, so I'm gonna go find the code that I already wrote and borrow it. There we go. Because I was looking for words that were close to other words. But I think I might have been looking at the, oh, that's wrong. That should be on that line. I might have been looking at the wrong thing. All right, so here I already had some words. So this gets the similarity between words. All right, so what I can do, because the other thing that might happen sort of weird here I like that little, if you're doing something more than once, you should probably put it in a function. That's true, past Rachel. That is absolutely true. We're going to need to do some things a little bit differently here. Because I only need one of them. I don't need, so I had similarity to the word he and the word she. So I'm going to change that to input. And I'm going to get rid of this. I'm going to call it input stem. Call this input. Go through and refactor real quick. Embeddings. There was this object that I had made earlier. Let's see. And it was from, oh, so this is the vector. So this is what I'm going to have to do to, okay, so I just read it in and called it embedding. That's all I have to do. So let's do that now. And I'm going to read CSV dot input glove, and I have some options. Which did I use here? I used 6,050,000,050D, which I think is, yeah, that's the smallest one. All right, so I gave it the input vector, get vector for input word. So this should be input, let's call it input vector, and let's create it input vector up here. And then we're going to copy and paste again. You know, copy and pasting and changing some things. That's the whole thing. And then this will be whatever the input word is. And then the embeddings is this. Okay, so these are the input words. This is my target that I want to change, and this is embeddings. So let's see if that works. 2 parsing failures. That's blah, the one column, blah, 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 blah. All right. What did I do last time? Oh, I see. It is not, in fact, a CSV. fread from data.table is what I used last time. So let's do that. I don't love data.table for everything, but if you're working with large data, it is very efficient because it modifies in place, which is a little bit scary. And I did fread here. Oh, zoop. No, I didn't. Sorry. I did do that there just now, but I actually want to do it down here. I'm glad I left myself that little comment about which package it was from. Good job, past Rachel. So this is kind of a hefty one because embeddings are fairly large. Big old matrices. And I'm actually going to load it in up here. Word embeddings. And I'll eventually move everything up to the top, so it'll be nice and tidy. Okay, so if we give this function a list of words, and then our input word, so cat, dog, pan, and then also mouse, another input word, and embeddings, which I think is just the thing that we've called embeddings. We can see, oh, we don't actually need the bias bit, so I can get rid of that. I don't remember where I put that in. Call name, similarity, rbind, input words, substitute words. Words I, dparse, substitute. I don't know off the top of the head what all that stuff is, so I'm just gonna leave it alone and we will ignore that column. How's that for a plan? David Nunes says, are you filtering embeddings every time you compute the similarities? Yes, because I'm going to be using a different set of words every time. So, yeah, I know that's not the most, David likes data.table. It's fine. It's just scary, you know? It's easy, if you're a beginner, it's much easier to, like, royally screw up with data.table than with Tibbles. Alright, so what this tells us is that for our input word, mouse, pan was the closest word, and cat and dog were further away, which is not necessarily what I expected, right? Bigger numbers are further away. I'm fairly sure. So, bias. Yeah, I think so. All right, so we would, yeah, so let's just sample 100 words from our frequency table, I think. This is the dumb way to do it, but and then the sampling is going to be what gives us non-deterministic qualities to our thing. Okay, so I'm just going to put that function up by itself. We will get back to it later and maybe get rid of that bias thing, whatever it is. So change all the words in semantically similar words using some sort of embedding. So now we have a way to do that. So what we're going to do is sample words, and we're going to sample from, we don't have environment variables. We're going to sample from the thing that we have called frequency underscore data underscore data, and because it wants a vector, we're going to say that the thing that we want is word, and we're going to sample 100, and then from there we are going to do word embedding similarity, and we are going to use as input the first thing from word, and then we're going to loop through it. Sample words, I believe is what we did. Let me check this. So word should be sample words. Sample words. And then input equals, what do we call this? Least common words. Least common words. Let's start with the first one because we index from 1 in R, like humans that count things. And then, what was the other thing? Oh yeah, just embeddings. Oop. This will take a minute. Oh, I made a mistake. Error in data.table embeddings I is an invalid data type matrix. Perhaps in future a 2-column matrix could return a list of elements. Please let DataTable help know if you like this or add your comments. Okay, well, all right. What is the thing here? Is it that it is not a vector? Let's try that. Let's try converting it to a vector and see how that works. All right. I don't know what this error is. Error in data table. Embeddings. Embedding 1 input 251 is an invalid type. Oh, okay. You know what it is? It's also got to be in the embeddings. I think that's why we're getting this error. So, and then I think I want to right join. I'm just gonna go back up and check what the other right join did, because I get it wrong all the time. So it was the big one and the small one. The big one is going to be embeddings, and it's going to be V1, because that's the first column has all of the words in it. Dot. Oh, actually, no, I should probably do left join and then switch the order so it's a little bit more pipeable looking. And I think this will give me what I want, which is words that occur in both lists. Not that they are lists. A new applicable method left join applied to an object of class character. Well noted. Is it that it's a vector? It is not. Okay. Let's check the type of this. See, I'm also mixing tibbles and data tables, which is not generally recommended. All right, it's a character. Oh, that's right, I'm an R. Oh, I have strings again. Oh, y'all have no idea. You have no idea how rough moving to Python and not having structures again was. It was the worst. All right, so what's the difference between the structures here? Is it set? Will that work? R get set to vectors. So I want only the things that occur in both. So discardingly duplicated. Oh no. Get common elements into vectors. That's what I want. Intersect. There we go. Excellent. So here we have some very good words that will definitely, you know, neurotoxic, make you feel that it could be any of these, right? All right, now let's try it. Oh, that still didn't work. Oh my goodness. I'm not sure what that was. I'll figure it out later. Because I'm running out of time. I said I could do this an hour, and maybe I can't. Well, okay, word embedding similarity. Oh. Whoops. Okay, so I think... Oh, maybe bigger is closer. So what word is this? No, it's a distant measure. It's a distance measure. So smaller is definitely closer. So coding, and then similarity to target. Do that, and then let me actually spell it the same way both times, huh? Similarity to target. What if it was the row minimum similarity to target input? So what I was doing was I was passing it the whole data frame and not just the single word I wanted. Operator for invalid for atomic vectors. All right. What does this data structure look like again? Okay. It is not, as you would think, a data frame. It's a character vector? Looks like a data frame. Does not quack like a data frame. It might be a data.table, actually. This might be why we're getting to weirdnesses. So why don't we do it as a data frame and then just like fix all our problems? Except it's not from Mia. Yeah, excellent. So the word was coding, and we're looking for the thing that's closest to it. And then let's arrange by input. Ivory's coding, Batista coding, the other power plant coding, create coding, Viagra coding, tactic coding. I think create's probably fairly close here. Let's go with the largest number, I guess. So top n, and then input, and I want just the top one. Selecting by bias. Nope, that's not what I want. And then I want to select word. So instead of power plant, it would say coding. And what would we call this? Replacement for input. Put equals input. Actually, let's get the top 5 just to make our lives easier. So it's a function. Oh, so first what it's called is get similar words. It's a function. It takes in the input. And then it returns. Nope. It returns placement, replacement for input. And if we do get that and we do it on that, we should get a list of 5 words, one of which is no, power plant isn't guaranteed to be one of the same words because we're going to be sampling every time. So could not find functions, returns. Yep, that's because it's return, and I was just saying words. So for coding, we got cuticle, reorganization, CML, geodesy, and Marlin. And I think reorganization is actually pretty good there, so I'm fine with that. And I am going to paste word. So we should get cannot convert glue. Could not find function glue. It's definitely installed. It's okay. That's not that important. For I in 1 through the length of words I print. So we're gonna print our 5 words to pick from, and we're also going to print our word that we are inputting so we can see both of them. And this is just gonna be a big old mess. But working first, pretty second. All right, so for coding, we got a bunch of things. Excluding, I guess, could be. We haven't gotten a way to deal with part of speech. For I'm, we've got, these aren't words. For automatic, we have court, gone, electromagnet, dipole, and ICU. For tweet, we have perusal, Reaper, mine, hotbot, and distro. For anonymizer, we have those things. For can't, we have butterfly fish, so that's helpful. Language, dentro, totus? Is that Latin? Oh, you know what? I bet ipsum lorem is super overrepresented in this because it's from web text. So yeah, there probably is Latin here. For reverse, we have ratings, philosophies, text, generations, and consonants. And for search, we have campaigners, unanswered, BMW, shorters, and hierarchical. And I think the thing that we can tweak here that will make it much slower, but probably give us slightly better results, is that. So that every time we sample just a lot more words. And I think that'll get us some good mileage. Oh, it's 455. In theory. All right, has that helped or is it still going? Yeah, it's still going. This is gonna take a minute. Let's add some comments. Function to get similar words based on to get the most similar words based on a 10K sample in a random 10K sample. And we've got a couple million, so I'm not super worried that we're just going to sort of like, if you just resample a lot, you're going to get the same ones over and over. Print the most common, the closest replacements for the suggested word, for the input word. So basically you'll get 5 suggestions per word. You can go to this one. It's still going. I'm keeping an eye on this one down here to see if the cell's still running. We can get rid of this one. We can get rid of this one. Word embedding similarity. Okay, those are 2 different functions, so we do want that one. Look at the least common words. Sorting by frequency. This we can probably get rid of because we know what that looks like. Get rid of it. Actually, let's just look at the head of this. Oh, and it won't finish running until that other one is finished running. Actually, you know what? I'm going to stop this. I think 10,000 might be too many. Let's try it. So let's actually try it just for 5 of these words, just so I can test a little bit faster. And let's, instead of 10,000, do 1,000. Well, let's keep it 10,000. 5 shouldn't be too slow, in theory. We'll see. 2 minutes. All right, so I think this is probably where I'm gonna end up leaving it for the day. So it's actually not so much tweets, it is the single tweet. Which is, that's okay. And yeah, think about emojis. I should probably move the frequency data up there as well, huh? That, and this is just, you know, tidying up, a little bit of house cleaning. Frequency info. And then at the end, telling myself a little to do. Pick and replace the target word from the tweet with a replace the target word from the tweet with a suggested similar word. No. Okay, we're gonna do 1,000 and we're going to do 1. All right, coding, smartphone, vernier, lenses, NHTSA, and driveline. And these were in both of those, apparently, in both the frequency and the word embeddings. So, oh, that's a good question. Yeah, no, I looked at the intersect, so I don't know. Smartphones is better. Again, it's not the right part of speech, but it's not terrible. How long does it take to do 10K? I'm getting distracted. I do need to wrap this up. I got an appointment at 5:15. Finish anonymization. But I think this is enough to get started. If you have some tweets you want to anonymize, this will suggest some words of, you know, varying quality. So you are going to have to sort of look at them with your eyes. I'm actually going to move this to do at the end as well. Sample script to help anonymize tweets to share in a paper by replacing the least frequent 20% of the words. I know the spelling is not correct. 20% of the words with words that are close to them in a embedding space. Yeah, no, they're not ideal. I hear you, David. David says, this is my gripe with embeddings learned from some other random data set. Yeah, and it's learned from web data, which, as we all know, is the cleanest and most beautiful of text data, and all produced by actual humans. So the suggestions for coding is learning. That's pretty good. I would absolutely use that. Ryan says anonymizer / obfuscator. Yeah, I like that actually. I'll add that. Obfuscator, because it does change the tweet. Although I think this one is in the word live coding, so it would be live learning, which I think that counts. All right. Thank you very much for joining me, guys. I do have to slip out now. I had a ton of fun, and I'm going to, so you guys can check it out. I'm going to make it public and commit it. So you can look at it and maybe play around with it if it's something that you're you are interested in. And yeah, I won't see you guys next week because I'm going to be at JupyterCon, which I'm really looking forward to. It's going to be so much fun. It's why I've been so busy this week. I've got so much to do, and it's not done. I'm going to be working all weekend, y'all. But it'll be worth it. And also, I won't see you. But the week after that, I should be back. So the 31st is when I will see you next time. And I'll tweet. And I'm assuming most of you are coming here from Twitter. So thanks for joining, and I will see you in 2 weeks.